We wish to analyze this truss using the method of joints. Let's start by calculating the support reactions. To determine the reactions, first we draw the free body diagram for the entire truss. Note the unknown reaction forces. We have labeled them Cx, Cy, and Ax. We need to write three equilibrium equations. The sum of the forces in the x direction must be 0, the sum of the forces in the y direction must be 0, and the sum of the bending moments, say about point C, must be 0. Let's solve these equations for the unknown reaction forces. From equation 3, we get, solving equation 2 for Cy, we get, then we can use equation 1 to determine Cx. Now that we have the support reactions, we can use the truss joints to calculate the member forces. We start by identifying a joint with at most two unknown forces. At joint C, we have members BC and DC, both having an unknown force. Let's draw the joint's free body diagram. Here we need to determine angle alpha. Now we can write the joint equilibrium equations. We have the sum of the forces in the x direction must be 0. The sum of the forces in the y direction must be 0. Using these equations, we can easily determine the two unknown member forces. We have a few more member forces to calculate. Let's look for another joint with at most two unknown forces. At joint D, we have only two unknowns, the force in member ED and the force in member BD. Here is the free body diagram for the joint. We don't need to determine any angles here. Now we can write the joint equilibrium equations. We have, using these equations, we calculate the two unknowns. They are, let's look for another joint with at most two unknown forces. At joint E, we have the force in member EB and the force in member EF. Here is the free body diagram for the joint. We need to calculate angle gamma. Now we can write the joint equilibrium equations and solve them for the two unknown forces. Let's look for another joint with at most two unknown forces. At joint F, we have the force in member FA and the force in member FB. Here is the joint's free body diagram. We then write and solve the equilibrium equations for the unknowns. Only one unknown member force remains, the force in member AB. We can calculate it using joint A. Here we need to determine angle beta. Since there is only one unknown force remaining, we only need one equation. Summing the forces in the x direction, we get, solving the equation for the unknown results in, we are done. Now let's summarize the results. Here are the member forces and the support reactions. Note that the zero force members are not shown in the diagram. A negative force magnitude indicates the member is in compression, while a positive magnitude means the member is in tension.